Everyone, so welcome to the second part of the 3D geometry. In this video I shall be dealing with the DCs and the DR and the Cartesian form of the straight line. So from the previous video we had learned that cos alpha, that is the direction cosine for the x-axis, will be equal to a upon under root a square plus b square plus c square. Cos beta was this and cos gamma was this. So we had measured the angle along the positive direction of the axis, but if we measure the angle, that is, first of all we had measured along the positive direction, that is plus sign. But if we measure the angle along the negative direction of the axis, that is 180 minus theta, then we will also get a negative sign here. So the direction cosines can be written as plus minus a by under root a square plus b square plus c square. Cos beta can be written as plus minus b upon under root a square plus b square plus c square, and cos gamma can be written as such. I had also proved that cos square alpha plus cos square beta plus cos square gamma was equal to 1. Okay. Now let me say that cos alpha has some value L. Let me take it to be L. Cos beta, let me say it to be M. And cos gamma, let me say it to be N. So what I can say finally, that L square plus M square plus N square has to be equal to 1 always for direction cosines. So I hope that this point is proved to you. So what I mean to say here is that if we have any vector which has the direction cosines as L, M and N, then the unit vector along that direction can be written as L I cap plus M j cap plus N k cap. Now why it is a unit vector? Because the magnitude of this will be equal to 1. Under root L square plus M square plus N square will be equal to 1. Thus this is a unit vector. So if we have been given any DCs, the unit vector along that direction will be given as L I cap plus M j cap plus N k cap. Now let us understand the concept of the direction ratios. Basically the concept of direction ratios is used for the derivation of the Cartesian form of the straight line. Let us understand them. So DRs, let me say that let A is to B is to C be a DR. That is, DR implies that these are a direction ratios for a particular thing. So let me say the simplest example, that is 1 is to 2 is to 3. So that is, we have these as the direction ratios. Now similarly 2 is to 4 is to 6 will also be a DR for this thing. Why is it so? Because if we multiply by 2 on all the three sides, we'll be getting 2 is to 4 is to 6. Now on the next step, what we can do? We can multiply by 3 is to 6 is to 9. So similarly we get the ratio 1 is to 2 is to 3 here. Similarly net, what I can say is that if we multiply 1 by any number x, that is 1x is to 2x is to 3x. So a direction ratio can have infinite values for any vector. See, it was 1 is to 2 is to 3. Here we have 2 is to 4 is to 6. Here we have 3 is to 6 to 9. Similarly, x is to 2x is to 3x. So we have infinite values of direction ratios for a particular vector. Thus, for any vector which has, let me say any vector, we have been given DRs for it as L, M and N. Then the vector can be given by as lambda into L I cap plus M j cap plus N k cap. Now why lambda? Because lambda is the constant which defines we have 1 is to 2 is to 3 or 2 is to 4 is to 6. If lambda is equal to 1, then we can get 1 into Li cap plus Mj cap plus Nk cap. If we have lambda is equal to 2, then this part, 3, then this part. So similarly you can see that we need lambda in order to define a particular constant for the direction ratios. So what we have learned till now, that we have a vector for which DCs are given as L, M, N. Then the unit vector along that direction will be given by Li cap plus Mj cap plus Nk cap. Also the value of L square plus M square plus N square is equal to 1, as I've shown above by the use of cos square alpha plus cos square beta plus cos square gamma is equal to 1. Now if we have any vector whose DRs are given as L, M, N, then the vector is given by lambda into Li cap plus Mj cap plus Nk cap, where lambda is any constant. Okay, so these are two basic things which people should know, that how to derive a vector by using a particular direction ratio or direction cosine. Now let us move on to the Cartesian form of a straight line in 3D. I shall be sharing some very important tips for solving these type of questions, as I've already studied this very well because it was very important too. So if we have a Cartesian form, it is represented as x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. Now let us see that what are the meaning of the terms and how is it derived for a particular case. So see, x1, y1 and z1 are the points through which the line passes. Okay, so if we have any straight line in 3D, then x1, y1 and z1 are the points through which the line passes, whereas a, b and c are defined as the drs of the parallel vector. So what I mean to say by the drs of a parallel vector, let us see the meaning to it. If we have any straight line here in 3D, then we have any parallel vector to it. See, parallel vector can be of any magnitude. Okay, now we take the dr for it. Dr of the parallel vector is taken into consideration. Why is it so? Because the drs of this line will be equal to the drs of this parallel line also, because the parallel vectors will have the same dr but the magnitude can change. As I've shown you that this was 1:2:3, so this can be 2:4:6, this can be something else, but the dr, that is the direction ratio, will remain same, that is 1:2:3. So basically, even if you take 2:4:6, that is 2, 4, 6. So the 2 term will cancel out, giving me 1:2:3. So that is not of a big deal. Okay. Now let us see that how to calculate the drs if two particular points are given to us for any vector AB. We have been given the vector, the point A as 1, 4 and 5. The point B is given as 2, 5 and 7. So we need to calculate the drs of the vector AB. So AB vector can be defined as OB vector minus OA vector. So AB vector will be equal to OB vector, that is 2i bar plus 5j bar plus 7k bar, minus, now what is the OA vector here, that is 1i bar plus 4j bar plus 5k bar. So AB vector will be equal to I bar plus j bar plus 2k bar. So this is the AB vector that we have got. Now the drs of the vector AB will be equal to what? 1, 1 and 2, that is these values. So 1, 1 and 2. So these are the drs. Now similarly, if you multiply AB by any lambda here, so that lambda can change accordingly, but the drs will remain same. As you can see, if we take it as 2, 2, 4, that is I multiplied by 2, the basic ratio comes out to be same, that is 1:1:2. So this is how the drs of a particular vector are calculated. So now let us solve a simple question on the finding of the equation of a straight line in the Cartesian form passing through these points A and point B. So first of all, if you remember that the equation was written as x minus x1 upon A is equal to y minus y1 upon B is equal to z minus z1 upon C. So where x1, y1 and z1 are defined as the points through which the straight line passes, whereas A, B, C are defined as the drs of the parallel vector. So first of all, let us find the ABC values. So let me say this to be vector A and this to be vector B. So AB vector will be equal to OB vector minus OA vector. So what is OB vector here? That is this thing, that is minus 1i bar minus j bar plus 3k bar. Now what is OA vector from here? You can see it will be equal to I bar plus 2j bar minus 3k bar. Okay, so subtracting these, AB vector will be equal to minus 2i bar and minus 3j bar plus 6k bar. So we have got the AB vector. Now what are the drs of this vector? Drs will be equal to minus 2, minus 3 and 6. Okay, so we have found out the drs. We know the point through which the line passes. The game is over. So let us put the values in. So x minus x1, that is x minus x1 is 1. You can take any point of what you want. So I'm taking this point here. So x minus 1 upon A is minus 2. Y minus y1 will be equal to y minus 2 upon B. B is minus 3. That will be equal to z minus of minus 3 upon 6. So basically it will become z plus 3. So this is the Cartesian form of the equation that we have derived. Now let us solve another question on it. So the next question is, we need to find the angle between two lines. So if you remember that, we need to first of all find the DRs. So let me take this line arbitrarily here. Okay, so this thing will be the value of the vector or the DRs of the parallel vector. So this is a line. Let me take the parallel vector to be this one. Okay, now this is the second line here. So let me draw the second line arbitrarily anywhere. Okay, now these are the values of the DRs of the parallel vector. So let the parallel vector be here. So we need to find the angle between these two lines. So if we find the angle between the DRs, if you remember from the concept of vectors, that you can just pick up a vector and place it as it is there. So we have this vector here. I pick up this red vector and place it as it is here. So if you find out the angle between the DRs of the vector, then that is the angle between the lines. So what I want you people to know is that angle between DRs of the parallel vector will be equal to angle between the lines. Now why is it so? It is basic maths that if the angle between two lines is like 30 degree, then the angle between the parallel lines will also be 30 degree. So let me begin with it. The DRs of this thing is equal to -1, 3 and 1. DRs of the second one is equal to -2, 1 and 3. So now let us write it in vector form. This will be equal to -1 I bar plus 3j bar plus k bar. Let us write this in vector form, -2 I bar plus j bar plus 3k bar. So we have taken the vectors from the previous page, v1 vector and v2 vector. So we know that the angle between two vectors is equal to, it is found out by using the dot product. So this is the dot product. So cos theta will be equal to a dot b upon mod a into mod b. So let us solve further. So cos theta will be equal to, now a dot b, that is this dot this. Let us put in the values. So -I bar plus 3j bar plus k bar dot -2 I bar plus j bar plus 3k bar upon modulus of a, that will be equal to under root. Now 1 square plus 3 square plus 1 square into modulus of b is equal to 2 square plus 1 square plus 3 square, or basically -1 square should be here and -2 should be here. So that is not a problem because it is squared. So that is very basic. So cos theta will be equal to -1 into -2, that is 2 plus 3 into 1, that is 3 plus 1 into 3, that is 3 upon under root. This will be under root 5 into under root. This will be equal to 9 plus 4, 13 plus 1, 14. Okay. Now, so cos theta from here will be equal to 6, 8 by under root. This will be equal to 70. So theta from here will be equal to cos inverse 8 by under root 70. So this is how you find out the angle between the Cartesian form of two straight lines. So in the next video we shall be discussing many more topics, and best of luck to everyone.